Okay, I think we'll get started. So we're coming back to pulse width modulation, and we're going to build off of the last lab. So very important, probably a prerequisite for this lab is to look at lab 7, where we go through a lot of the important registers that we need to use in order to do pulse width modulation. And as if you recall from that video, what's neat about the pulse width modulation is that it's a separate peripheral. So once you get it going, it just performs its pulse width action without having to utilize the CPU. So it's different than a bit banging approach to making doing pulse width, which you certainly could do. Now, what we did there was just get that going. So what we want to be able to do is change the duty cycle on the fly. So that's going to be the most basic thing we're going to do here is just we're going to toggle between one duty cycle and then another duty cycle. Now we're building towards the next video where we're going to actually be able to call a function for the duty cycle, but to lay down the foundations for that, and so that we don't have to do so much work in that next video, we're going to just see how this works with two states. So we do our pulse width setup, and this is really coming from what we talked about in the previous lab. And the big difference here now is we're going to pull the CCPR1L register inside the main loop, because we can write to that on the fly. And that's what's neat about the pulse width modulation. It's not just a set and go and then it's locked in, which could be useful for timing purposes, but what makes it really useful is if we can change the duty cycle. So that would be for like dimming lights or controlling motors and stuff like that. Very important. So we're going to set this to a small duty cycle. So we'll see an output on our scope that looks like that. A little bit of a delay, half a second or so delay, and then we will write to this register again and write to it such that we have a larger duty cycle, and then a delay on that, and then we just loop through that. So very much like a blinking like a blink program, but now with the pulse width modulator. And in fact, we will have a LED hooked up so that we can see the dimming effect of that. A little harder to see on the camera, but if you're doing it at home, you'll be able to definitely see the dimming effect of a larger duty or a small duty cycle compared to a larger duty cycle. Okay, well, let's get to the computer and get going on this. Okay, so just show here, in fact, we see it's going right now, but we'll go through everything from the start. And yeah, you can kind of see it blinking here, as I mentioned, dimming and getting lighter, but a little bit harder to see. I'm going to try to turn this to the side, maybe a little easier. Okay, so simple, very, very simple circuit. Our pulse width is coming out of RA2, and we're just running that through an LED and then a 470 ohm resistor back to ground. We're going to power everything with the PIC here. It's easy to, it's not a very difficult circuit, so no problem powering that with the PIC. So I've got a, keeps getting upside down. I got a PIC kit 5 here, and that will be powering this PIC through our setup here. And I've got, let me just pause the video very quickly and I'll show you the scope. Okay, so yeah, I've just got this one camera that has to work for both me and the scope, but hopefully you can see here the pulse width changing as we change the light level. I'm not taking it all the way wide because there's a large region where it's really indistinguishable from visually indistinguishable from the light of the LED. So it turns out you want to be closer to the dim side to really see a big difference. But we will make some changes in our code to change the size of this, so we'll see that as we look at the code. So let's go ahead and look at the code. I'm going to pause it again to get the camera back in place. Okay, so I've got the MP Lab up. I'm going to skip the setup. We did that in the previous video, and we've done it in some other videos. So if you are brand new to this and just need to get yourself going, go back and look at video 7. You'll want to look at that anyway. So that goes through setting things up, getting the right microcontroller, making sure you select the proper PIC kit, and so on. So we'll just start from saying we've already got everything up. We've got our main.s file ready to go, ready to type into. Okay, so let's go to my GitHub page, and we'll grab under the PIC12F1822. This is going to be, the first lab was pulse width LO. I should have just named it pulse width 1. Here's pulse width 2. And so we'll go ahead and grab this quickly and go back now to here, and I'll just paste this in. Okay, I'm going to make sure everything works here. So we want to build and build successful. And so now I'll try to load it to the chip. We shouldn't see anything changing here because this is the same code that's currently running. Looks like it worked. Okay, so let's walk through the code real quickly. Again, just as a refresher, this stuff, well, all this stuff is the configuration bits, and then where the program starts, and all this is calling in the library for this particular, for all the chips actually, and so it knows it's a 1822. So here's where we really start. All of this is largely standard, and we really just fiddle with this if we want analog to digital. We don't want any of that right now, so we're just going to clear the AND cell to make that 0, to make it all digital input and output. And then we have to set our tris. We do want the pulse width as a output, so we want to make sure that pin 2 is output. So here's pin 0, pin 1, pin 2, that's a 0, and a 0 is an output here. And that gets sent to the tris, and so that sets our pins as inputs and outputs. Here is the PR2, and we talked about this last time. So we went through the calculation there to give us about 20 kilohertz, and so that's our setup there. Then this sets the prescaler that's related to this. So this was, we talked about this T2 con, and the CCP1 con is also for our duty cycle information, and the type of active pins and so on. So this is all back in the previous video. The only thing we would probably pull out at some time, and we might do a video where we do this, is if we make a change of the, well, we will do a video where we do this, where we make a change in the pulse width frequency. So you can also pull this into a loop where you're writing to it as well. But for now, it's solid. It's just going to stay at this, and we're just going to change the duty cycle, which is a very common thing you'd need to do. So here's our CCPR1L register, and we're going to pull that now. We're pulling that into the main loop. So this is what we use to calculate our duty cycle, and so we went through that calculation as well last time. So we're just going to make some changes here. So very simple, 0, 0, 0, 0, 1, 0, 0, 0, and then we're going to change it to 0, 0, 1, and then 5 zeros. So we'll do this. We'll send to a delay, a short delay, then come back. Now, important here, in order to call the delay, I've got those set up with these registers, and that's on bank 0. And the CC, and this is, I think this is bank 5. Yeah, this is bank 5. So we need to go to bank 5, change the value, then we have to come back to bank 0 in order to utilize the delay. So that's an easy place to chase your tail. When we use this delay as we've been using throughout the series, that's on bank 0. Then we have to come back, and when we come back, we have to change back to bank 5, and then change this register, and then change back to bank 0 as we loop through. Yeah, because we need this delay here. And then the process just repeats and repeats and repeats. Okay, so I will, let's see, I think what I will do is move the camera over to look at the scope. I'll keep it in this view so that we can see the changes in the code, and then I'll go full view on the scope after that. So let me pause, and I'll move the camera. Okay, so here's the same as we were seeing earlier. So now I'm going to go up in here, and let's just change this. I'm going to just bump this up and change that down. So I'm just going to slide this 1 over, and we should see a much larger, much fuller duty cycle here now on this larger half. So we see much larger, and I can go over 1 more even, I think. Oh no, I think that's too far. And I'll put a 1 here, and then run this. So now I'm almost a full duty cycle on, a full duty cycle off. So we're getting pretty close to just on, off here. Take a quick look at the scope mode here. Again, sorry for the blurriness, but let's put some measurement on here. And again, I'll just have to report to you. So this is the 19.6 kilohertz, which is exactly what we timed it out to be. And so I'll turn this off now. Oh. Okay. All right, so that is, let me bring. Okay, so that's how we control the duty cycle. And again, we can use it for a dimmer switch or controlling a motor, that sort of thing. So the next lab, what we're going to do is ramp this up through a triangle function. And this is going to bring in a very clever idea about a lookup table that is a pretty fun and interesting thing to use.